Now here's a table that summarizes everything for you. You see, when I talk about solids, they are in a very closely packed order. As you can see here, yes, very closely packed in an orderly manner. Forces of attraction, that's what I told you, attractive forces, very strong. Kinetic energy of particles are very low. Particle movement, particles vibrate and rotate about their fixed position. So that really means is the only energy that they have is that their particles just vibrate and rotate about their fixed positions. And then there are further 3 points, which is shape, volume, and compressibility. What that means is shape. Let's say, for example, for a solid. Now, solid has a fixed shape. Imagine a door. A door has a fixed shape. A cupboard has a fixed shape. A bed has a fixed shape, right? So everything that is solid is going to have a fixed shape, right? Volume, it's again, you see, definite really means that the shape is fixed. Definite means that it's not going to change. Same goes for the volume, right? So the volume for a solid will always remain the same. The volume of the bed will always remain the same. It's not going to change in an air. It always remains the same. Okay. Now, compressibility, what does that mean? Compressibility means if I apply a lot of pressure, I mean, if I press something down very badly, is it gonna compress? It does not. Solid in this case does not compress. So anything that is solid, let's say for example you have a syringe, okay? I draw a very bad drawing, by the way. I don't know. It's something like this. I feel like, yeah. Let's just consider that syringe. And inside that syringe, you have sand particles. Now, sand is what? Sand is solid. And if you try it from this particular thing, I don't know what it's called, but if you try to press it downwards, it's not gonna press downwards. Why? Because solid cannot be compressed. Okay, that's your idea. Then let's look at liquids. Liquids, I told you, they are closely packed to an extent. You see, there are different ways to write the same thing. You can write that it's less closely packed compared to solid, or you can also write it's closely packed in a disorderly manner. Now, the force of attraction are less strong. The kinetic energy of particles is also low compared. You see, what we are doing is comparing the values. So in solid, it was low, it was very low, and in liquid, it's a bit low. Okay. Then the particles can slide past each other. What that really means is that, let's say you are standing in an assembly in a school, and let's say you are a solid. Now what that means is, if you're standing in a school in an assembly and you are a solid, that means at the place that you're standing, you cannot move away from that, anywhere from that place. But when you are a liquid and you're standing in an assembly, then that means that you can probably swap places. You can go behind the line or in front of the line. That's what really sliding past one another, sliding or moving freely around one another, that really means. Okay. Now, particle movement in gases, that means they move very quickly. So one thing that you need to know about, I might have forgot to add this, is that in gases, the particles, they move at very high speeds and in random directions. Okay. So let's say you have this box, and in this box you have got gaseous particles. So at one moment this gaseous particle is going to be here, at one moment it's going to be here, might be here, and then here, and then here, and then here, and then here. So it moves at very high speeds and in random directions. Okay. Okay. Again, then let's get back to the shape for liquids. The liquids, it does not have a fixed shape. It has an indefinite shape. What does that really mean? For example, if I take a half-liter of water, right, and I pour it into some jug, so what's going to happen? It's going to take the shape of the jug. If I pour it in a cup of coffee, it's going to take the shape of the cup of coffee. So the liquid in question, I put it in anything, it's going to take the shape of that particular thing. If I put it in a box, it's going to take the shape of the box. So what do we say about liquid is that the shape of the liquid, it's determined by its container, meaning wherever we store that liquid, wherever we put that liquid, it's going to take its shape. That's what that means. Okay. So for example, I'll also give an example. Let's say I put it in a bottle, right? So now liquid is now taking a shape of the bottle, right? So wherever you put it, it's going to take its shape. Now, but it has a definite volume. What does that mean? It does not have a fixed shape, but it has a fixed volume. That means is that if I put, let's say, if I take 0.5, or if I take 1 liter of water, I put it in a jug, I put it in a box or anywhere, the volume, that 1 liter is not going to change, right? Unless you probably drop the bottle, you know, somewhere and the water flows out, right? So the volume remains the same. The shape can change, but the volume is gonna remain the same. The mass that, sorry, the space that it occupies, that is going to remain the same. It's going to remain 1 liter of water. Okay, that's the idea. Compressibility, again, same example. If in place of this sand, if I take water and I try to compress it, it's not gonna compress. It's not gonna be pressed. The syringe won't go down further. Okay, so it cannot be compressed. Now let's look at gas, for example. Now the example of gas is, it does not have a fixed shape. Why? Because gases, they really don't have any shape whatsoever, right? So, and you cannot even say that they take the shape of their container, or you can say, or you can actually say that, it does not have, again, like liquid, it does not have a fixed shape. You put it in a cylinder, in a glass, or anywhere, it takes its shape. Water, of course, we can see liquids, right? But we cannot see gases. So it takes the shape of its container. About volume now. Now, volume, again, for the gas is not fixed, and you can question this actually. You can ask me that, okay, what you said was that, if I take half liter or 1 liter of water, and even if I swap the containers, the amount of water remains the same. Why not? It is the same with gases, and I'll tell you why. Because let's imagine you have a balloon, and you have one smaller balloon, right? You have one smaller balloon, and then you have a larger balloon. Okay, so if in this particular balloon, if I pour, let's say, 1 liter of water in this small balloon, and then in the larger balloon, the volume remains the same. Okay, the volume remains the same, it remains that 1 liter. But what happens with gas is, the particles in gas are so far apart that if I take, let's say, some certain quantity of gas in this smaller balloon, it occupies the whole area. And when I when I put the same gas under in the same condition, or the same quantity of the same gas in the larger balloon, or in this one, it will take the entire space in the balloon, right? So gases, you can just say, जिसको हम उर्दू में कहते हैं ना कि जितनी जगह दो उतना फैलता जाता है. That's what gases actually are. So if you put it in a smaller balloon, it's gonna take it's gonna take that volume of the smaller balloon. If you put it in a larger balloon, it's gonna take the entire space that is present inside that balloon. Okay, so if I put it in a smaller box, तो वो सारे box की जगह ले लेगा. If I put it in a larger box, gas will take the space of the entire box. Why? Because gaseous particles are already very far apart from one another, and as I told you, they can spread apart, and they move in very high and random directions. Okay, I hope this part is clear. The last part is compressibility. Again, yeah, this is important. Again, let's take a syringe. Okay, let's take a syringe. And in this syringe now, what you have is, at this point, till this point, you have what? You've got a gas. You've got some gas. Now, when I compress it, it's gonna compress. The needle is gonna go down. Okay, the plunger, I think that's what it's called. It's gonna go down. Why? Because gases can be compressed. Okay, because if you have, let's take an example for the syringe again. If you have a syringe, even if we have air inside it, air is also a gas, right? So even if we don't have anything inside the thing, what we still have is gas. What we still have is some air. So when we press that thing down, it does go down, right? And the reason it goes down is because gas is compressible. Even if I had oxygen at this place, even if I had oxygen, you know, even then it would go down because gases are compressible. That's the idea. I hope this part is also